All right. Scatter plots, lines of regression. Any data with two variables is called bivariate data. Bi like bicycle meaning two, variate meaning like the word variable, so two variable data. The graph of bivariable data or bivariate data is called a scatter plot or dot plot. It's called a scatter plot because bivariate data is rarely organized neatly. I know we're used to doing lines, but life isn't linear. It's more messy. Depending on the agreement of the values, the correlation coefficient R can range from values of -1 to 1. This is more, again, this is stuff you should have seen last year, but this is more just so you understand it in case it pops up. If you are looking at something like this, -1 would be like a perfect straight line of information. 1 would be like a perfect straight line of information. And so if you're looking at this, and you're having to guess, notice how these points are going in a positive direction. So this would be more like 0.5 because 1 would be like a straight line of dots. So that would be more like 0.5 or so. Again, if you get into statistics, you'll see this. Notice that these dots are moving more in a downward direction, but again, they're kind of scattered. So therefore, again, I would call this -0.5 because it's negative and it's not really a straight line of dots. It's a scattered range of dots that are definitely going in a downward direction. And then if you look at the third one, those dots really don't look like they're going anywhere, and that would be 0. So in other words, I can't tell if it's positive, can't tell if it's negative. So again, in terms of R, when you read this, this is a positive direction, so you want to give it a positive correlation coefficient R. This is definitely going in a negative direction, so you want to give it a negative correlation coefficient R. This has no direction to it, so you say, I don't know what direction it's going, it gets a 0. Each correlation coefficient that is not 0 can be summarized using a line of best fit. What that means, it's a line that would be expected at a certain value. So line of best fit should be placed so it goes to the middle of the data. Before discussing the line of best fit, let's just talk about some scatter plots because again, this is stuff you should know since you saw it before. They're talking about depth and temp. Remember that the first variable is, or the first thing in the part is usually your independent variable, so depth and temp, which I probably shouldn't have wrote so close, but we'll be okay. So depth goes from 0 to 2,000. So I need to be able to get to 2,000. So 0 will be here. 1,000, 2,000 is too much. I have to find a way to get to 2,000 that uses the information the best. So counting by 1,000 doesn't work. 5, 1, 5, 2, nope. What about 250? 250.5, 75, 1, 250.5. Yeah, I think that'll do it. So 0, 1, 2, 3. That'll be 1,000, 1, 2, 3, 4. That'll be 2,000. And at least that gives me an idea. I put 100, of course, because you know me. But again, what that does is you can kind of assume that that's your 500, 1,000, 1,500, 2,000, but at least I have it labeled so that whoever reads it can kind of figure out what's going on. Your temp goes from the lowest range of 6 to the highest of 22. Let's see, 6, 7, 8, 9, 10, 11, 12, not enough. What about 2, 4, 6, 8, 10, 12, 14, 16, 18, 20? You know what, I think that'll work, so we'll just count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and we'll understand 22 is pretty close. Now you just plot them. 0, 22. Here's your temperature of 0 or your depth of 0. Your temperature of 22 is here or about there. Again, it's a scatter plot. 300 leads to 20, so we'll go to the depth of 300, which is 500's here. 300 would be about here. And it said 300 goes up to 20, so 300 would be 20, which is right about there. 500 leads to 13. Remember those two numbers. 500 leads to 13, so 500 would be 13, which is in between 12 and 14. 1,000 leads to 7, so 1,000 is definitely here. 7 would be slightly or in between 6 and 8, which is right here. And 2,000 leads to 6, so 2,000 here, 6 here. Pretty much that's your scatter plot. Doesn't look like anything special, but we should be able to see that it has a more negative, as we would say, negative correlation because the dots are definitely going down, which pretty much means that as you go deeper into the water, the temperature is seemingly going to drop. Now we don't know exactly what it's going to be, but that's that. All right. If you had to draw a line of best fit, you would simply draw a line that would simply go through the best portion of everything. It would not be a line that would meet everything, but there would be your line, something like that. Again, when you do your line of best fit, there is an equation for it, but if you just had to sketch one, you want something that kind of goes through the middle of everything. Family, size, and income. So here we go. This is going to be family size, and income, I'll just put the $sign. Family size is going from 1 to 4, so I don't think I want to go 1, 2, 3, 4 because that doesn't spread it out enough. I need it spread as possible. So how about 1, 2, 3, 4? I think that'll work better. Even though we know there's no such thing as a family size of 1.5 or 2.5, but at least that does give me a wider range so I can kind of see everything move. Your income is going from 33,000 to 59,000. So pretty much I need to be able to get to 60,000. 10, 20, 30, 40, 50, 60. I don't think it's going to work. 10, 20, 30, 40, 50. I think we'll just have to go with that. So 10. Actually, you know what? We can just go ahead and start where we want. So we'll start out 20, 30, 40. Actually, 20, 30, 40, 50, 60. So that's where I'm going to go. So 20,000, 30,000. 40,000, 50,000, 60,000. In terms of your scale, there are different rules, but the general rule is as long as each of those steps represents the same amount, what I did is I kind of skipped over a portion and just jumped into a range that I need. I would not start at 20 if there is a 5,000 somewhere down there because it would throw it off. But because my range is between 30 and 60, this actually will give me a nice accurate amount because they're evenly spaced. What you don't want to do is go 20, 30, 40, 50 and then just kind of skip over things differently. I know it's 20, 25, 30, 35, 40 and so on. So family size of 1 is about 33,265. 33,265 would be higher than 30, less than 35, somewhere around there. Again, it isn't going to be perfect. Just should make sense. 2 is 44,625. 44,000, so 45 is here. It'd be slightly less than 45, somewhere around there. Family size of 3 is 50,528. So family size of 3 is 50,000, which means I'm right around 50,000 right there. Again, not perfect, but close. And then family size of 4 is 59,000, which is almost 60, so a little bit lower than 60, so somewhere around there. And once again, you can see it's not a straight line, but your correlation coefficient would be pretty high, because these are pretty straight. The reason they're pretty straight is because you only did 4 different family sizes and probably 4 people. But if you had to pick a line of best fit, you want something that goes to the middle. It would be something like this. And again, I never was good at this stuff, but that does kind of go to the middle of everything. Everybody's about the same distance. So the actual line of best fit is found by approximating its location and then choosing 2 points to write an equation. Actually, your graphing calculators that you'll see later on do it, but again, you'll see that in statistics. So the skill we covered in 2.4 is what we're going to use. So the first thing we would do is make our scatter plot. So the year goes from 2002 to 2008, which I think we can do. 2001, 2, 3, 4, 5, 6, 7, 8. Yep. 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008. This is your year. And your number of employees goes from 4 to 25. So 5, 10, 15, 20, 25 is not enough. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. What about 3s? 3, 6, 9, 12, 15, 18, 21, 24. Yep, so we'll go with that. 3, 6, 9, 12, 15, 18, 21, 24, 27, silly, 30. And so now, 2002, the number of employees was 4, so it's above 3. Again, it's not going to be perfect. You just want to make sure you're about where you need to be. 2003, it was 7 employees, so 2003 is above 6. 2004, it was 11 employees, so 4 goes to 11, which is going to be closer to 12. 2005 is 14 employees, so 2005, 2 less than 15, which is going to be somewhere around here. This is almost straight, which means I'm really messing up, but it's okay. 2006 is going to be 20, which is lower than 21. 2007 is 23, which is lower than 24. and 2008 is 25. So 2008 would be higher than 24, which would be somewhere around there. You are going to be doing this process, so make sure you pay attention to what I do next. First off, you will be making a scatter plot. Remember, I'm not going to grade your scatter plot for perfection. I'm going to grade it off of making sure that there's not a point where your 3.7 is somewhere here. It should look about the same. It's not going to be perfect, but it should look pretty close to where it's supposed to be. The key thing I'm going to look at is when you create your line of best fit, which is what we're going to do now. And when you create your line of best fit on MathXL, use the first and last points. Even on your test, just use the first and last points. That's not the way you do it. I'll just tell you that. That's not the way you do it. But just to make things consistent, use the first and last points and go from there. So your first point was 2, what's right here? 2, 4. Your second point was 8, 25. And as I said, back in 2.4, we covered the ability of writing an equation of a line. So what that does is now it says we have to find a slope. So 2, 4, 8, 25, which means we do 25 minus 4 over 8 minus 2, which is 21 over 6, which is 7 over 2. We then take that 7 over 2 and 1 point. We do y equals mx plus b. We plug in our y, which in this case is 4. We plug in our m, which is 7 over 2. We plug in our x, which is 2, plus b. We multiply up, which actually makes it nice because it ends up being 14 over 2 plus b, which ends up being 7 plus b, which means that in the end you subtract your 7, getting negative 3 for b. So your equation would be y equals 7 halves x minus 3. That's it. To test it, I would use one of those 2 points to make sure, but again, for the most part, 8 gives us 56 over 2. 56 divided by 2, I believe, is 28. 28 minus 3 is your 25, which is what you're looking for. But you do need to at least make sure you can show me that process, which is the key point. But again, in terms of right now, for what I want you to do, just pick the first and last point. There will be people in statistics and other things that will say, find the 2 best representative points. But even more than that, the reason why I'm not going to go that deep is because your graphing calculator actually takes these points and will give you an exact line of best fit. And there's no need for us to go and hurt ourselves that much when there's technology that you'll be taught to use later on. Which equation could be a prediction equation for the data points shown in the scatter plot below? I believe this is one of your interim measure questions. Please use your common sense on this. Watch this. First off, it's a positive correlation, which means my slope should be positive, which means I can eliminate A, because remember, that's your slope. Second thing is my y-intercept should definitely be somewhere in the upside, not in the negative 200, so I can eliminate that one. So now it just comes down to what's going on here. And so what I would do is, if I'm taking my interim measure test, is I would use my calculator the way my teacher has taught me, because he's taught me both ways, and I would take my slope. So you have about 150 going to 1,000. And you have about, let's say that's 500 going to, let's say 800. I'm sorry, 1,800. And so I will use that to do second minus first, so 1,800 minus 1,000 over 500 minus 150. You get the answer of 16 over 7. Now here's the nice thing about it. This double arrow is a conversion key, so if I hit this conversion key, it's going to give me about an estimate of what it should be. So about 2.28 is my slope. Okay? Is 2.28 the same as 5? Not even close. But what's 11 divided by 5? Well, it's 2.2. Hey, that's pretty close to 2.28. It's got to be this one. So it's a fighting question. It's a question that requires you to do a little bit of thinking. But again, if you use your tools, and that's why I tell you to do it on paper, but I also want to make sure you can use your calculator, because there will be times that you don't want to write all that stuff on paper. You just want to get a real quick check to see how things work, and it does help to know how to do. So outside of that, just make sure you're keeping up. Make sure you're asking questions as you need to. I'll talk to you later.